Hello. Make sure that before you watch this video, you watch the one that says Elimination 2, Example 1. It'll make so much more sense if you watch that one first. This is the one where you actually do need to write some things down. Now, the first thing that you should write down in your notes is, just in case you're still having a hard time by the end of both of these videos, for other research, aka solving by linear combination or linear addition. There are three names for this technique of solving solving systems of equations. I don't know why they give it so many names, but they do, and some videos are under any one of the three. It can be called solving by elimination, linear combination, or solving by addition. Now, for your notes, I'd say title these ones solving by elimination with multiplication. That's a good general description of this. So let's say we've got two equations. We've got there we go. 4x minus y equals -7, and -3x plus 2y equals 9. Now let's see. Could we use substitution? Well, potentially we could without too much trouble, because this y is by itself, but we're still going to use that this time. And could we immediately use elimination? Could we add or subtract these two equations to get rid of a variable? Let's see, 4x plus -3x would just be x, so it didn't get rid of it, and -y plus 2y would just be y, so that wouldn't get rid of it. If I subtract them, it still wouldn't. Thankfully, we have another technique where we can still use elimination in a slightly different way. So first we're going to say step one, number the equations. So I'm going to call this top one equation 1 and the bottom one equation 2. Now, step 2. Multiply each term in one of the equations by a useful multiplier. Now what we mean by useful is, useful means it'll help you eliminate a variable. So let's see, could I multiply 3 by something to get 4, or 2 by something to get y? Well, okay, I could, but it would have to be a fraction. There's something easier I can multiply by. If I multiply -y by 2, I'll get -2y, and if I add those together, it'll get rid of the y's. So next to step 2, write ex2. Now I'm going to create a new one. Which in this case is going to be 2 times 4x minus y equals 7. The 7 is still times 2. And that becomes 8x minus 2y equals 14. Now step 3. Title your new equation 1b or 2b. Because I made this new equation by multiplying equation 1, I'm going to title this 1b. Step 4, combine and eliminate. So now because I made this equation out of number 1, I'm going to combine it with number 2. So I'm going to say 8x minus 2y equals 14 plus equation number 2 was negative 3x plus 2y equals 9. So now 8x plus negative 3x is going to be 5x. Negative 2y plus 2y is 0. And 14 plus, oh, I'm sorry. Sorry, that was negative 7 up at the top. So this is negative 14. So negative 14 plus 9 equals negative 5. So I've got 5x equals negative 5. So now divide both sides by 5 to get x by itself. And we'll get x equals negative 1. Now that I have figured out my first variable, x, we come to step 5. Substitute found variable in any of your 3 equations, or rather, not any, easiest. So let's see, I've got equation 1, equation 2, and equation 1b, the one that I made myself. Well, let's see, which one has the smallest variables? 3 times x wouldn't be too much trouble, but I'd end up with that whole double negative situation. I think that equation 1 is the easiest to use. So I'm going to say 4, because it's 4x minus y equals 7. So I'm going to use 4 times negative 1 minus y equals negative 7. Then I will say 4 times negative 1 is just negative 4 minus y equals negative 7. Add 4 to both sides to get almost y by itself. Those 4's cancel. We'll see negative y equals negative 3. Divide by my secret coefficient of negative 1 to get rid of these negative signs. We'll see y equals 3. My final answer is x was negative 1, y is 3, negative 1, 3. And there we go. Take a moment, make sure you get this first example down. The next one is going to be a little more complicated. Now for the last form of solving by elimination. This is a case where I can't add or subtract my equations together to immediately eliminate a variable, and there's no easy number that I can multiply one of the 2 equations by to make it so that I can eliminate one. Because let's see, there's no easy number I can multiply 3 times to get 2, or 2 times to get 3, or 4 times to get 5, or 5 times to get 4. It would have to be some kind of a fraction that I could multiply by. And we'd try to avoid fractions in multiplication when we can usually, right? Because we like to do things the easiest way we can. So let's say I've got these 2 equations. I've got 2x plus 5y equals 3, and 3x plus 4y equals 2. Step 1 in this type of situation is multiply both equations by useful numbers. And what I mean by a useful number is a number that'll help me to eliminate one variable in my new equations. So I'm personally going to try to get both of these to have 6 in front of the x. I want a coefficient of 6 in front of x's. Because like 3 times 2 is 6 and 2 times 3 is 6, I can get to 6x pretty fast. Whereas with the y's, I mean, the closest number I can think of, the smallest number I can think of that 4 and 5 go into is 20. little bit harder than 6 to work with. So let's make our new equations here. I'm going to multiply my first equation times 3. So I'm going to say 3 times 2x plus 5y equals 3. Again, all times 3. So that's going to give me 3 times 2x is 6x plus 3 times 5y is 15y. And 3 times 3 is 9. So now I've got a new equation, and I'm going to title it 1b, because I made it from equation 1. Now I'm going to create an equation 2b, because I want this to turn into 6x at the front here. So I've got 3x plus 4y equals 1. Let's see, what can I multiply 3 times to get 6? It's 2. So I'm going to multiply everything in equation 2 times 2. So I'm going to say 2 times 3x plus 4y equals 1, all times 2. So that gives me 6x plus 8y equals 2. And since I made this from equation 2, I'm going to title it 2b. So that's what we say, step 2, label both new equations, and the rest of the steps are the same. Now I'm ready to put them together and add or subtract. So I've got equation 1b, 6x plus 15y equals 9. And equation 2, 6x plus 8y equals 2. Let's see. What do I need to do to get rid of a variable? Do I need to add or subtract? I need to subtract. So when I subtract 6x from 6x, I'll get 0. And 15y minus 8y is 7. And 9 minus 2 is 7. So I've got 7y equals 7. Divide both sides by 7 to get y equals 1. Now, I can substitute this y equals 1 into any of the 4 equations. I can use one of the ones I made, 1b or 2b, or I can use one of the 2 originals. I think that number 2 looks the easiest to use. So I'm going to use number 2. I'm going to use 3x plus 4y equals 1. So in 3x plus 4y equals 1, I'm going to substitute 1 for y. And say, okay, so that's 3x plus 4 times 1 equals 1. So that means 3x plus 4 equals 1 minus 4 from both sides. I'll get 3x equals negative 3, divide by 3 on both sides. And I'll get x equals negative 1. And that leads me to my final answer of, since x was negative 1 and y is 1, negative 1, 1. And then you're finished.